All right, so if we want to do number 26 out of 7.6. I don't know what's beeping. All right, I would like to give a possible formula for something that's in the book, right? So what am I pulling off of this picture that's important? Okay, it looks like tangent. There's a 10 here and a kind of tangenty looking curve going through that. And then where are these vertical asymptotes indicated?
X over 8 and pi over 8.
I think they're, yeah, pi over 8 and negative pi over 8. And then, of course, this thing kind of repeats, right?
Yeah, that's not.
What's up?
Is that important? How we keep repeating?
Only in that it sort of clues me into the idea that this is probably actually a tangent function. Like, if it was just that middle one with those two vertical asymptotes, I'd be a little skeptical or something. I'd be like, oh, maybe I need to restrict the domain or something weird, right?
I mean, when you're writing the formula, you're supposed to follow.
Yeah. For the formula, I'm really just going to focus on this middle one. So what do I see out of that? I see there ought to be a tangent function, right? And there's definitely an up 10. You guys see where we got the up 10 from?
Mm-hmm. Up 10.
It's been squished by a factor of 2 or is it 4?
Well, I don't know. Where are those usually?
Pi over 2.
Pi over 2, so it's 4.
Yeah, good. So this is usually at pi over 2, and this is usually at minus pi over 2. At least it's symmetrical, right? Like if this one was at pi over 8 and this one was at like minus pi over 16, then I would have a much harder time with this. You guys all see that?
What would you do then?
I'd have to deal with some kind of horizontal shifting business and ugh. So thankfully I don't have to do that. So let's see. How do I squish by, I want to squish by a factor of 4,
Yeah.
right? So I put a,
1 over 4.
yeah, it's either a 4 theta or a 1 over 4 theta, right?
4.
So how do I check which one it is?
You just do pi divided by the thing in front of it.
Yeah, okay, so you could remember the period squishing formula, or you could think to yourself, okay, when I plug in pi over 8, right, in my thetas, I should get pi over 2 before I take the tangent. You guys see that? So if I plug in pi over 8 and multiply by 4, I'm going to get pi over 2.
Pi over 2, yeah.
You guys all see that? So I can double check that at least. Okay, what else do I need?
I think that's it.
Yeah, done? Circle this?
Yeah.
No. What else do you
Y
need?
equals.
Why do you box it in?
Function.
Yeah, because I need to add something to the box. I just need to name it something.
I like
Yeah,
that.
why?
Right, so this is a function. It gets a name. You can name it whatever the hell you want, but you got to name it.
Well, they label the axes, so that you usually have to go by the axes.
No, not really. This axis definitely has to be named whatever they labeled. Right, so the input variable specified, that's theta. And this output axis, right, is labeled y. But that's just kind of traditional, right? This doesn't have to be on a theta y graph. This doesn't have to be y of theta, right? Because I don't graph, you know, normally when I do this, right, I call this thing f of x, right? But that's on an x and a y. You guys see that? That output variable is just the name of the outputs. It doesn't have to be the name of the function. You certainly could use it as the name of the function if you wanted. Cool? Check? That said, don't name it like x of theta or parenthesis or other bullshit. Right?
Theta of theta.
Yeah, definitely don't name it theta of theta. Cool. So there are some things you should probably stay away from. Like the usual function names. right? Like tangent's the name of a function already.
Oh.
I shouldn't call this tangent of theta because tangent already means something.
Mhm.
I should probably also stay away from things like square root symbols and exponents and all sorts of
James
other
of theta.
Cool. But yeah, you can name it whatever you want. So if you want to call it James of theta, go for it. Cool.
Okay.